A very good afternoon to all my lovely students. Very good evening, Ruduvarsham. Yes, good evening. Hello Rajesh. Hello Karthik. Hi. Good evening. Good evening. How are you all? How are you all doing? Quickly tell me. How was your yesterday's class? How are you today? Bad evening. Why Satya? Why bad evening? Good evening Lokesh, Manoj, Fatima. Good evening. I am very good Aradhya. Thank you. I am also good. How are you? Good evening Sunita, Manoj, Anivesh, Edward. Yes. Sir, tomorrow holiday? Tomorrow, why tomorrow holiday? Tomorrow is working now. Yes, Sriram, good. Sana, Zarmeen, I am also good. Khalil. Okay, so many students, that's very good to see. Have you all liked the video? First you tell me. Yes, Tali, it will be explained again. Lokesh, I have had my lunch, thank you. What about you? I am also good. Thank you, Glam Studio. Do I have throat pain? Not throat pain actually. I have some pain in my jaw actually. I got one surgery done a week back. Good evening, Deepthi. All right, everyone. Tomorrow is Good Friday. Yeah, happy Good Friday to all of you, those who are celebrating. Yes. Okay, everybody. So yesterday's chocolate question, I'll explain, Ms. Ba. I'll explain. Don't worry. If you have not liked the video yet, quickly like the video first, then I'll start. Okay. 40 likes are there. 40 likes are there. 250 students are there. First like the video, then we are going to start with our today's lecture. Sushant, I don't know yet this thing, but let's enjoy our next 20 days the most. Okay. Already 5-6 classes are over. Thank you, Suresh. Let us enjoy our next 15-20 days, how much ever time we have together. Yeah. So let us start, everybody. Like the video, 82 likes are there, 270 people. What is this? Fast, quick. Be fast. 109. Good. Quickly, let's reach to 300 likes and let us start then. LOL. No LOL. This is important. Okay. Important for my motivation. Okay. Your motivation comes when teachers tell you something motivating, but our motivation comes when people say hello, hi to us, and when you say good morning, good evening, and when you like the video, when you say, sir, you are teaching well, and all these things motivate us also. Okay, tomorrow's holiday, I don't know, Himavati, I think there is no holiday tomorrow for the lectures. You can attend the classes or you can attend it later because recording anyways is happening. Okay, all right guys, let us start. Today I am going to teach you very important part of mole concept chapter, which is called as stoichiometric calculations. First we'll start with that topic. Okay. First we will start with that topic, stoichiometric calculations, and then few more questions of mole concept we'll practice. Okay. I have got you few more questions for mole concept like this question, but these I'll tell you at the end. Okay, two chocolate questions for you as well today. Good. If you've liked, good. Today we'll start with our stoichiometric calculations. Okay, all of you can see this figure here. Okay, all of you can see this figure here. Stoichiometric calculation means when a chemical process is happening, how do we calculate the amount of product or amount of reactant? That is called as stoichiometric calculation. Okay, that is called as stoichiometric calculations. Means calculations, you can write it down, of the amount. Amount may be mass, amount may be moles, amount may be volume, any of these things when we try to calculate. Calculation of the mass, moles or volume of any chemical species, in a chemical reaction. Simple unitary method is going to work here as well. Same crisscross method that you have stop talking to each other now, everybody. Okay, carefully listen. Okay, carefully listen. Same crisscross method will work here also, whatever we have used in the mole concept topic. Stoichiometric calculation में just one extra step is there. We'll have to write a reaction and balance it out. For example, as you can see this figure here, can you see this figure? That is how you prepare a sandwich at home. You take 2 bread slice, 1 cheese slice, and you get 1 sandwich. Okay, this is how you prepare a sandwich at home. Here I can use the stoichiometry, simple stoichiometry. I'll ask you one question. You can tell me the answer. Okay, question is, how many sandwiches, or first this question let us do. How many bread slices are required to make 12 sandwiches? Tell me everybody. Tell me. How many bread slices are required to make 12 sandwiches? Quickly tell me. How many breads for 12 sandwiches? Good evening, Aparo. Hi, Alia, yes. 24. Simple. If you know that 24 breads are required, then you can do all the stoichiometry questions. You can do the all stoichiometry questions. How do we say? Simple crisscross will apply. The reaction was 2 bread plus 1 cheese give 1 sandwich. Okay, this was our, so this is called as stoichiometric coefficients, 2, 1, 1. This 2, 1, 1 are known as stoichiometric coefficient in a balanced reaction. Then simple crisscross only we have applied. What crisscross we have applied? We are comparing breads with sandwiches. So I am saying I am keeping bread here and sandwich here. Okay, this is a simple unitary method you have used, that one sandwich require 12 bread, one sandwich require 2 breads. So 12 sandwich require 24. What you have done actually is crisscross only. When breads are 2, sandwich is 1. When breads are 2, sandwich is 1. When sandwiches are 12, breads are x. Cross multiply. So what we have done here is this only. We have done x is equal to 2 times 12, which is 24. Simple. Okay, Panda bro, Jaswant, celebrity, what all you are saying, funny boy. This is not funny, everybody. Devil Potter. Okay, keep yourself little more disciplined in the class. How you used to behave in your 10th class, same way you should behave in 11th class and 12th class. You guys are going to become doctor very soon. Okay, you know how doctors behave, correct? Devil Potter, you know how doctors behave, no? How soft spoken doctors are. When you go to a doctor, he'll never be shouting things like some of you guys shout. So becoming a doctor, it's not exactly that 5-year MBBS that you do, then you become a doctor. No. Attitude needs to be developed from class 11th only. From class 11th, you start becoming a doctor. Start behaving like a doctor. Automatically, you will become a doctor. Okay. That is how doctors behave. If you were, if you were in JEE background, then I could have expected that, okay, no problem, you are little, jolly, fun-loving and all. But doctors are not like that. Doctors are very responsible citizen. Most responsible. We call them God, no? So if you want to become a God, G-O-D, if you want to become a God tomorrow, then you have to behave like one. Okay, good. Now, so this is clear, 24. Next one, you tell me how many sandwiches can be prepared if 11 cheese slices are there? Quickly. How many sandwiches can be prepared if 11 cheese slices are there? If cheese slices are 11, then sandwiches can be how many? Quickly tell me. 11. Very good. Very good. Simple crisscross once again you have done. Simple crisscross once again you have done. This time you are comparing cheese slices versus sandwich. Sandwich here and cheese slice here. So when cheese slice is 1, sandwich is 1. 1 sandwich comes from 1 cheese slice. 11 cheese slice sandwich are x. So x is 11. This is the very first type of questions that you will get. Simple questions. Okay, what are simple questions? Where they will give you data of one of the reactant and ask you either product or another reactant. Okay, let us now start this first type of questions. How to do them, all of you quickly see here. Okay, all of you quickly see here. This is the first type. Second type will be, if I give you number of cheese also and number of breads also, then can you tell me how many sandwiches will be made? If I give you some cheese, some breads, tell me from this figure. If you have these many breads, you can all count the breads yourself. Count the breads yourself. Count the cheeses yourself. And tell me how many sandwiches are you going to get here? How many sandwiches are you going to get here? Quickly tell me. How many breads are there? Sir, breads are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 breads are there, sir. 10 breads are there, sir. How many cheeses are there? 1 cheese slice, 2 cheese slice, 3 cheese slice. How many sandwiches? Very good. 3 sandwiches. 3 sandwiches. Correct? Why 3? Why not 5? You to have 10 breads. 10 breads could make 5 sandwich, but why you are not able to get 5 sandwiches here? Tell me. Because, sir, cheese will finish first. Cheese will finish. We can't make 5 sandwiches because the cheese will finish. I'll take first 2 breads. I'll put 1 cheese in between. 1 sandwich is done. I'll take first 2 breads. Put 1 cheese in between. 1 sandwich done. I'll take next 2 breads. Take 1 more cheese in between. 2 are done. I'll take 2 more breads. 1 cheese in between. 3 sandwiches are done. Now after this cheese got over. Cheese got over. What is remaining? Still I have 4 breads remaining. 4 breads remaining. So whenever you do a reaction, many times this will happen. Many times this will happen. One of the reactant will be finished first. We call it as limiting reagent. Remember it? Name itself tells you, no? Limited amount. Limiting reagent. How much reaction will proceed, how much product will form, how many sandwiches will form, only depends on the reactant who will finish first. Even if I took 10,000 breads, still I could make only 3 sandwiches. No DMR, not as per question 5 you cannot make. Okay, so what did I say? Whatever thing will finish first, that will decide how much product will form. Bread is useless here. Bread is useless. Whatever becomes useless is called as excess reagent. Excess reagent. So what is excess reagent? The reactant which is remaining after the reaction. Limiting reagent is what? Reactant which is consumed. Quickly write down. Which is consumed the earliest. I have not told you any chemistry till now. Simple basic things I am telling only. And what is excess reagent? Reactant remaining after the reaction. Reactant which does not get finished. Okay. These are definition only, Sushant. What else am I writing here? How to do limiting reagent problems? Tomorrow it will come. Tomorrow it will come. Okay. All right. Yes, completely consumed reactant will decide the product. Tomorrow these type of questions will come. Today only simple type questions. Okay, question number 1. All of you see here, I am telling you, first question I will do. First question I will do. Second question you will do. Are you all ready? Yes or no? Are you all ready? Yes or no? Reagent means reactant only. Dhanalakshmi. Janvi, you don't need definition right now. Janvi, you don't need definitions right now. You are no longer in 10th class, okay? Whatever I am telling you, that is important. Not whatever you want to listen. Correct? Yes, good. All right, everybody. Question is, what mass of CO2 gas can be produced by decomposition of 5 grams calcium carbonate? Now the first thing, step 1 that you will have to do, step 1 is write the balanced reaction. Always in the stoichiometric question, write the balanced reaction. Yes, so balanced reaction, calcium carbonate decomposition. If you have seen this reaction before, that is very good. Otherwise, you can keep remembering it now. When you take calcium carbonate, it breaks down to give calcium oxide solid and carbon dioxide gas. First thing that you do is balance the reaction. So first step, write balanced reaction. Write a balanced reaction. You can balance just by hit and trial, not a problem. 1 calcium balanced. 1 carbon balanced. 3 oxygen balanced. So the stoichiometric coefficients are 1, 1, 1. Stoichiometric coefficients are 1, 1, 1. Now, next 3 steps. Everybody look at this. Okay, I know you are getting the answer. Everybody look at this. Just after writing the stoichiometric coefficient, then you will write the mole data, the mass data, and the volume data. All of you can easily write it according to stoichiometric coefficient. So if stoichiometric coefficient are 1, 2, 3, means 1 mole, 2 mole, 3 mole you write. Here 1, 1, 1, so I'll write 1 mole of calcium carbonate gives 1 mole of calcium oxide and 1 mole of CO2. Now according to this 1 mole, I can say 1 mole of CaCO3 weighs how much? 100 grams. Its molar mass will be 100 grams. You can check. Calcium is 40 gram. Calcium is 40 gram. Carbon is 12 gram. And oxygen molar mass is 16 gram. 100 gram. 1 mole of CaO will weigh 40 plus 16, 56 gram. And 1 mole of CO2 weighs 44 gram. Volume data. When you reach to volume data, please remember that volume at STP, that number 22.4 liter, was only valid for gases. So whenever you see a solid, you say volume, we don't know. We don't know what is the volume. If we wanted to know the volume of a solid, I would require its density. By looking at the stoichiometry, we cannot write what is the volume. We don't know. It is a solid. We don't know. Yes, this is a gas. 1 mole of a gas occupy 22.4 liter. Now, crisscross. Crisscross. Now, crisscross. What are we comparing? I am comparing mass of CO2, which is here. Can you see? Mass data of CO2. This one I am comparing with mass of CaCO3, which is this. These two are going to be compared. Weight of CaCO3 100 gram, then CO2 is 44 gram. Crisscross. Crisscross. Okay. Everybody who is studying with good, concentration, you can reply. 100 gram I am comparing with 44 gram. So I am saying here I am keeping CaCO3. Here I am keeping CO2. If CaCO3 is 100 gram, then CO2 is 44 gram. In the question they are saying CaCO3 taken is 5 gram. Then CO2 is X. Crisscross. Crisscross. Okay. So what do we get? We get 100 times x equal to 44 times 5, x equal to 2.2 gram. That is the answer. Okay. B option is correct. Very good. B option is correct. You could have done it by unitary method also. This is also unitary only, but I am telling you this is easier method to do crisscross. By unitary, you would say that 100 gram CaCO3 produce 44 gram CO2. So 100 gram CaCO3 gives 44 gram CO2. 1 gram CaCO3 will give 44 by 100, and 5 gram CaCO3 is going to produce 44 by 100 into 5, which is 2.2 gram. Any which way you want to do, crisscross is easy. Is it clear to everyone? Yes or no? First question easy only, na? Everybody, quickly say easy peasy in the chat box. Like the video, then say easy peasy if this is easy for you. Yes, this is unitary method, Aradhya. Unitary method, crisscross, both are same only, beta. There is no difference. Nali Padmavati, just like CO2 is a molecule, no? CO2 is a molecule. Covalent compounds are called as molecule. Ionic compounds are called as formula unit. So sodium chloride is a formula unit. It's not a... Sir, usually will they give a molar mass? They'll not give. You have to learn the molar masses. Slowly you will learn. As more questions will keep coming. Yes. And also keep remembering the reactions of everybody. All the reactions I will tell you, you have to remember. Now next question, I am giving you 1 minute to solve. All of you do this. Next question is for you. If you are all ready, I will give. Next question. Yes, do this yourself, everybody. I am writing the reaction because you don't know many reactions. Calculate moles of O2 produced by decomposition of 490 grams KClO3. This is how KClO3 dissociates. KClO3 is a solid. On heating, remember it, it gives KCl solid plus oxygen gas. Do it yourself, quickly. We don't know means what is the exact number of STP solid. Beta, if I take this phone, if I take this pen, okay, their volume depends on what is their density. Okay, density of plastic is different, density of metal is different, density of gold is different. So whenever you take any solid, to find its volume, density must be known. Density equal to mass by volume. So we don't know what is the volume because I don't know what is the density. But for gases I can take. Tell me the answer. Good, Srinu, Kumara, good, Akshara, good, Mahita, good, Glam Studio, YouTube, good, Prince. All of you are giving correct answer. Very good. Step 1. Step 1, balance. Without balancing, nothing can be done. Without balancing, nothing can be done. Yes, good. First, I'll balance. 1 potassium, 1 potassium, 1 chlorine, 1 chlorine. 3 oxygens. Here there are 2 oxygens. Now you have seen different ways of balancing. 3 and 2 can be balanced. If I put a 3 here, then oxygen becomes 6. And I put a 2 here, then oxygen becomes 6. 2 KCl, 2 KCl. So 223, these are the stoichiometry. 2 mole, 3 mole. Simple type of question. Breads are given and sandwich is asked, or sandwich is given, bread is asked. So decomposition of 490 gram KClO3 means bread is given, how much sandwiches can be formed. This is the type of question it is. So 2 mole will weigh how much? I will now only be concerned with the mass of KClO3 because I am comparing mass of KClO3 with the moles of oxygen. KClO3 2 mole means how much mass? 2 mole means 2 times 122.5 gram, which is the molar mass of KClO3 I have given you here. Okay, so I am comparing this thing, mass of KClO3, I am comparing with the moles of oxygen. These two things I am comparing. I am leaving everything aside. I am not concerned with the molar mass of KCl. I am not concerned with volume of O2. Okay. So we are only concerned with his mass and his moles. Correct? So we'll say, looking at this unitary method, we'll say 245 grams KClO3 produce, I am doing unitary, you can do crisscross, produce 3 mole oxygen, and 1 gram will produce 3 by 245 mole oxygen, and 490 gram is going to produce 3 by 245 into 490 gram, which is 6 moles, is the answer. Simple, easy peasy lemon squeezy. If you have done the answer correct, quickly like the video. 195 likes are there, 400 people are watching. What is this? Okay. If you have done the answer correct, then like the video. If you have not done the answer correct, don't dislike. Study again. Study again. Become smart. Okay. Become mature. Will not take much time. Next, sir, if we put 3 by 2, then also we get, yes, that is also one way to balance, but most of you will not be comfortable with the fractions. That's why I have not used. That is also correct. Crisscross also correct. Okay. Done. Are you ready for the next one, everybody? Swati is ready. Are you ready for the next one? Are you ready for the next question? Do crisscross, do whichever method, beta. So many times I have done crisscross. No. Do yourself now. Thank you, Niranjan. God bless you. Next one. Next one. Do this one. Do this one, everybody. I will not write the reaction. I hope everybody knows what is Haber's process. Yes. Question is, what volume of hydrogen at STP will produce 6.8 grams of ammonia gas? Don't know the process. N2 plus H2 NH3. All of you have passed your 10th and 9th, no? You have studied the combination reactions, N2 plus H2 NH3. All these are gases. Balance yourself. You have done the balancing also. Don't make me feel that I am teaching someone from 6th standard. Okay. All of you are well versed with the balancing and little bit about the types of reaction you can get. Okay, Tanu had got the answer. Tanu has got the correct answer. Good. Meena Kundana has got the correct answer. Good Meena, good Tanu, good Nikki, good Suma. Very good, good. Thank you, Victorial Software. Good. Yoga Amrutha, good. Amrutha has got the correct answer. Good. All right. First thing, balance the reaction. N2 plus H2, NH3, 2 nitrogens, I'm making it 2 here. Nitrogens are balanced. Hydrogens are 6 here, here only 2, I'll triple it, it became 6. So stoichiometry become 1 mole reacts with 3 mole to give 2 mole. If you want, you can write the whole data. Let me write the mass data. 1 mole nitrogen means 28 gram. 3 mole hydrogen means 3 times molar mass of hydrogen, which is 2 grams, so 6 gram. And 2 moles of ammonia means 2 times 17 gram. Ammonia is 2 into 17. And because I am asking volume, since it is a gas, 1 mole of any gas means 22.4 liter. 3 moles of any gas means 3 times 22.4 liter. 2 moles of any gas means 2 times 22.4 liter. This is the volume data. Now the comparison is between volume of hydrogen, which is here. This is going to be compared with mass of ammonia, which is here, mass of ammonia. Let's do crisscross. Let's keep volume of hydrogen here. Let's keep mass of ammonia here. If volume is 3 into 22.4, then mass of ammonia is 34 gram. When mass becomes 6.8 gram, volume becomes X. And then cross multiply. Cross multiply. So what do we get? We get 34x equal to 6.8 into 3 into 22.4. Okay. So x comes out to be 6.8 into 3 into 22.4 by 34. Now as we know, 34 ka double is 68 only. So 68 5 times will go 34, exactly 5 times. So we get here 67.2 by 5, which is 13.4. 13.44 liter is the answer. 13.44 liter is the answer. So this is another simple question. This is first type of question where you know the number of breads, you are trying to find the sandwich, or you know the sandwich, you are trying to find the cheese. I did not tell you that N2 is this much and hydrogen is this much, then how much ammonia will form. That would become a limiting reactant type of question. If data about all the reactants is given, then only it is a question from the limiting reactant. If I say 100 breads, 20 cheese, then you have to think who will finish first. If I say 100 breads, 20 cheese, then you have to think who will finish first. Same way, if I tell 200 nitrogen, 500 hydrogen, then how much ammonia, then you have to think who will finish first. Accordingly, we'll write the answer tomorrow. Okay. Tomorrow we'll be doing the questions from limiting reactant. Shall we go to the next one? Is it clear to everyone? Say yes or no. Shall we go to the next one? Clear or not clear? Clear or not clear? Is it clear to everyone? Software KT Vlog says, I have a lot of patience. My patience comes from your smile and your, success. If you are successful, I am patient. Okay. Yes, good. Some of you might be thinking it's not clear because you are coming late in the class or going early, because in the starting of the class for first 10 minutes, only 200 students are there. Okay. Yes, good. I'm moving to the next one. Those who are not clear with it, please watch the video once again. Everything will be clear to you. Jyoti Ravi, Rohita, please watch the video once again. Okay. Niranjan, you also. Next one. Do you all know what is combustion? Can you write combustion reaction? Combustion reaction is whenever a hydrocarbon reacts with oxygen to give CO2 plus water. Remember this reaction now. Combustion means, so question is how many molecules I am asking, how many molecules of oxygen gas are required for complete combustion of 2.5 moles of methane gas. So I'll think, what is the reaction? Combustion. Combustion means starting with our fuel which is methane gas here. Methane is CH4, everybody knows. Combustion means burning it with oxygen. How you do combustion in your body also, no? In the respiration, you do in the digestion process, glucose plus O2, CO2 plus water. Same way. Methane plus O2 give CO2 plus water. Whenever you write combustion reaction, water must be taken as a liquid. Don't take water as a gas. Okay? Do not take water as a gas. It must be liquid. Okay? This is the one. So, balance it now. 1 carbon, 4 hydrogen, 2 hydrogen, double it, 4 hydrogen. Now oxygen, this side 2 oxygen, this side 2 plus 2, 4 oxygen. So I'll double it. So stoichiometry become 1, 2, 1, 2. Now get the answer quickly. Get the answer. Get the answer. I am waiting for you. Just like you have written the moles data, you have written the volume data, you have written the mass data, you can write the molecule data also. You know 1 mole contain Avogadro molecules. Okay, you know 1 mole contain Avogadro molecules. Sir, physical states are gas, 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 liquid. And my seat is being booked to Sridhar sir, principal of 11 to. Sir, will you teach there? Okay. Please do not worry about other things right now. Okay. Only focus on the questions. Please, I request this to everybody. 5 mole, 5 Na. Good. 5 Na is correct. Everybody is correct here. 5 Na is the answer. 5 Na is the correct answer. Okay, quickly I'll just solve it. I have to compare moles of methane, which is here, with molecules of O2. 2 mole will contain 2 Avogadro molecules. These two things I have to compare. Okay. Once you have found what 2 things to compare, use unitary method. In unitary method, I told you, always on the left hand side, keep the known thing, what you already know, and right hand side, keep the unknown thing. What do you know? You know the moles of methane. What do you not know? You don't know the molecules of O2. Okay, so left hand side I'll keep methane. So when methane 1 mole is taken, 1 mole methane produce 2 Na molecules of oxygen. 1 mole of methane produce this much. So now 2.5 mole will produce how much? It's already unitary. 2.5 mole methane will produce 2 Na times 2.5, which is 5 Na. This is the one. Good. Clap for yourself if you have done everything correct till now. Clap for yourself. Lasya, you can't identify. Lasya, you have to remember. You have to remember which is solid, which is liquid. Okay. If I just give you a randomly randomly if I give you any chemical, benzene. Do you know what is benzene? Whether benzene is liquid or solid or gas? You don't know, you have to learn. If I tell you it is liquid, then you know it is liquid. So benzene is a liquid, benzoic acid is a solid. Slowly as you move on in the class, all these physical states will keep coming. and then you keep remembering them. Keep remembering them. Okay, Niranjan, there is no problem. Till the time you are happy, I am happy. Once solved, I have solved already, no? Done? Ready for last question? Let's do a chocolate question now. Let's go back to the mole concept. Okay, so these are the questions I brought from the unitary method part. Now let's go back to the mole concept. All of you can see here, this was the yesterday's chocolate question I gave you. This was the yesterday's chocolate question I have given you. Let us look at the question. All of you see here. Calculate number of electrons in 1.8 milliliter water at STP. Now the thing is, water at STP means 0 degrees Celsius. Water will not be a gas. Okay, water is not a gas. So for water, we cannot write that number 22.4 liter ever. Water is a liquid, and we know density of water is 1 gram per ml. Density of water is 1 gram per ml. So quickly see what to do here. When I talk about water, let's write the mole concept of water here. Let's write the mole concept of water here. Number of electrons I am searching. I am searching number of electrons in 1.8 ml water. 1.8 ml water. That is the question. So I'll write the mole concept of water. I'll say 1 mole water. If I take 1 mole of water, it will weigh 18 grams. That is the molar mass of water. And 1 mole of water will contain Avogadro number of molecules. Okay, till now everything is clear to us. 18 gram will contain Avogadro number of molecules. Now when you take 1 water molecule, in 1 water molecule, how many electrons are there? In each water molecule, how many electrons are there? Each hydrogen has 1 electron, all of you know. Each hydrogen has 1 electron. So 2 hydrogens will have 2 electrons. Electrons is always equal to atomic number. Hydrogen has atomic number of 1 and oxygen has atomic number of 8. So oxygen will have 8 electrons. So total 10 electrons are present in 1 water. In 1 water, there are 10 electrons. So in Na waters, there will be 10 times Na electrons. Now since water is a liquid, I cannot write 1 mole as 22.4 liter. This is completely incorrect. It is a blunder that you will do. It is almost like saying this. Have you ever seen 22 liter of water? Yes, you have seen. Full bucket of water is 22.4 liter. 1 bucket holds 20 liter or 25 liters of water. Now what you are saying is 22 liters of water is 18 gram only. 18 gram water is just a sip of water. 1 sip of water is 18 gram, this much water. And here you are taking a bucket. So it's not at all correct. If it was a water gas, means if it was a steam. Now how much volume does steam occupy? Steam occupies a lot of volume, as you know. Then 18 gram will occupy 22.4 liter. So when I take 1 bucket of steam, it will weigh 18 gram. But when I take 1 bucket of water, it will weigh 20 kilogram. Yes or no? 20 kg. So for a water liquid, never write volume 22.4 liter at STP. It is completely incorrect. Then what should I say? I should say, sir, what is the density of water? Density of water is 1 gram per ml. Means weight by volume is 1 gram per ml. So when weight is 18 gram, volume also must be 18 ml. When weight is 18 gram, volume also must be 18 ml. So I can say 18 gram of water is also 18 ml of water. This is the correct thing. Okay. So when you take 18 grams of water, this much water, it will have 18 ml of science helper. Hybridization will be done. Are you doing this particular problem? Right. So 18 ml. Now what are we going to compare? We are going to compare volume of water with the electrons. So we'll say 18 ml water contain 10 Avogadro electrons. So 1 ml water will contain how much? 10 Avogadro by 18 electrons. So 1.8 ml will have how many? 10 Na by 18 into 1.8, which is Avogadro electrons. This is the answer. How many have done it correct? Please reply with a thumbs up if you have done it correct yourself. If you got trapped somewhere, just write trapped. If you got trapped somewhere, if you took it as 22.4 liter, just write trapped. If you have done it correct, just show a thumbs up, like the video, and then we will meet tomorrow. Quickly like the video. All of you, those who are clear with the concept, like the video. Those who are not clear with the concept, watch the video again, then like it. Okay? Yes, good. So many have done the correct answer. Sahiti got trapped. Kushal got trapped. Okay, Hasini got trapped. Good. Sahit. Now next time, don't get trapped. Lavanya. Write on the top of this question, never take water volume 22.4 liter. Never ever. 22.4 liter means a bucket of water. Sriram got trapped. Sudha got trapped. So many got trapped. That's a good thing. Once you get trapped, you learn from the mistakes. Good. All right. Bye bye everyone. Take care. See you all in the next class. Bye bye.